ಅಪಾರ್ಟ್ಮೆಂಟ್ ಏನು ಉಪಯೋಗ
Hey all, good evening. Welcome back to Polkadot India Substrate Saturday BootCamp. And today we have our guest speaker with us to give you guys an overview on how things work in the Web3 world. Also, today marks the last session of the 3-month-long bootcamp series. We're almost at the end of this bootcamp, and congratulations to all you guys for making it so far with us. It's definitely a commendable effort, and I'm sure it's not easy to pull yourself together and sit on a Saturday afternoon to learn something. So yes, it's definitely great, and kudos to you guys. Keep it going, and good luck to all of you who's made it till here. And yes, good luck for your Web3 journey ahead. So let's begin. So Polkadot aims to create a fully decentralized platform for exchanging tokens in a peer-to-peer trustless environment, while also enabling high liquidity, lightning fast transaction speed, and advanced trading features such as high-frequency trading and trading bots. Polkadot was bootstrapped by a Web3 grant at the initial stage of the project to develop the original idea and was accepted as a member of DeFi Alliance. Polkadot believes in the power of DeFi to set people all over the world free financially. So today we have our guest expert from this amazing project with us. Please join me in welcoming Faisal Ahmed, who's a Rust developer at Polkadot. Today he'll be conducting a live workshop on introduction to testing of substrate palettes. Super excited to have you with us, Faisal, and the stage is all yours. Do we have Faisal with us?
I think he had to drop out. He will join back. Just
Sure.
give it a minute or two.
Yeah, sure. So meanwhile, just keep an eye on the chat box, guys. We'll share the links to our community channels for you guys to be in touch with us going forward. Also, we'll announce the placement process ahead soon with some clarity on who's eligible to apply. So look out for the same.
We have Faisal with us, Kavya. We can start.
Over to you, Faisal. I got welcome back. Can we make him the host? Hello, hi Faisal, are you around?
I think Faisal, can you unmute? Yeah.
Am I audible?
Yes, yes.
Cool.
Hi
All
Faisal,
right.
welcome.
Hey everyone. I'm sorry for the delay. I think I went into a Google Meet and then I realized it's a Zoom meeting. So yeah, sorry about that.
Sure, you can take over. Welcome again.
So hey everyone. For those of you who don't know me, so my name is Faisal and I work at Polkadot as a junior Rust engineer. And I've been working, with Substrate for around 6 to 8 months. And I'm no expert, but I have a good understanding of how things are going on. And I think before that, I've been a part of a couple of open source fellowships, and I'm all open source enthusiast about it. So I think in this session, I will try to explain you about how we go about testing a substrate palette, and what are the different things you can do about it, and all possibilities with it. So one of the key aspects of it is that we normally think of unit testing as just a function where we give a XY input and then we get a Z output and we just verify if that is the output we need. But when you think about a substrate palette basically runs inside the blockchain. So for to actually unit test that palette, we actually need something called as a state. So if you think of blockchain, it's basically a state machine. You give an input with the state and you get a new state. So basically in Substrate, we have a couple of tools that allow us to mock this state so that we can just easily, verify our logic of our extrinsic. Uh, again, I'm under the assumption that there is a good amount of knowledge transfer that has already happened with the bootcamp because I think this is the last session. So I'm just throwing terms around. So if someone has difficulty in understanding what I'm saying, feel free to ask a question. So basically, what Substrate does is it provides tool that you can easily verify your logic without having the hassle of running the entire blockchain and then submitting transaction and then seeing the output. You could do it in a mock environment. And that is what I will be talking about in this entire session. And we will be going through, the entire code of it as well. So for this session, I've created an example palette where users can basically mint, create their own assets, mint for themselves, and then create an airdrop. So other participants can join that airdrop, and at the end of it, the owner can basically execute this airdrop where he can give this assets to them as part of an airdrop. So I think I'll just begin sharing my screen. Before I begin, does anyone have any questions that I can address or any concerns? Uh, Hey James, uh, yeah, I think I haven't been active on social media, I guess, for the last 2, 3 weeks as I've been a lot of juggling between work. So I will look through it. So yeah, hello everyone. So I think I'll just share my screen. Uh, okay, just give me a second. I think I'm not used to Zoom. Mhm. Okay, just give me 1 second. I'll be back.
Just give us a minute. We'll check.
I think I'm not able to share my screen. It's been disabled or something right now.
Yeah, hi.
Hi. Mhm. Okay. Yeah.
Could you also please come on video if that's okay?
Yeah. Yeah. Give me a second. I'm not able to see my controls. Yeah. Cool. So I think I will first run this node that I've already compiled. I hope my screen is visible. Can you all see a VS Code or?
Yeah, we can.
Yep. So can you see Polkadot Explorer right now?
Yes.
Awesome. So in this session, we basically have this palette. I just named it. This is the old palette that we used to use. So because of time, I've just not renamed it. So over here, basically, we will allow users to register an asset by giving it an asset ID, asset name, asset symbol, and the amount of decimal it needs to have, and how much we want to initially mint it for that owner. And then once we do this, we allow a user to register a drop. So basically, he can say that this is my asset one, and I will allow around 10 participants, and I will give them amount of 10 per participant. So once that is done, people can come and participate in it as join drop. So they can just use this extrinsic and put the asset ID. So I'm not using a hash or anything. It will be directly mapped to an asset ID. So they can directly press an asset one or two and join the drop. And once there are enough participants in this drop, the user can basically execute the drop. That would basically mean he will transfer the amount 10 to all the participants. So just to see this in action, before I do that, let me just go to sudo. And for folks who are new to this, so sudo basically allows me to do whatever I want. So here, what I'm trying to do is that I want to set balance for a couple of test accounts so that I can sign transactions. Uh, so I will be giving them some balance in the native currency that has been assigned for this runtime, and I will do it for two accounts. So that will basically load these accounts up with some native currency that I will use for signing the transactions. And now that I have done that, I will go back to the extrinsic, and now I will go to my palette. And what first thing that I'll be doing is register a new asset. So I will give this asset ID one, and I will name it substrate Saturday dots, and I will give it a symbol of S dot, and I will say it has double decimals, and I want to initially mint an amount of 1,000. So that would be 1,000 into 10 power 12. That would be 10 power 15. That would be 15 zeros, 12, 13, 14, 15. And now this will basically register an asset, which we will see over here. It will not only register the asset, it will register the asset, set the metadata, and then it will mint an initial amount of 1,000 assets into this account. Now that we have the asset register, now I will create a drop. So this would be same because we initially registered it to be an asset ID of one, and I will say the maximum participant that can participate in this would be 10. And for each participant, I would give 10 units. So this would be a very small value that would go around 0.000, I think, into 10 power minus 11 or minus 10. So it's not necessarily 10 because we define the decimals to be 12. So now I will submit the transaction where I've created this drop. So once this is done, I can have other users join in. So we've registered this drop. Now I will have someone join it, and by just giving this asset ID, uh, so I can have some other user. So we basically registered everything with Purdy. So we will do it Eve, and now we have a user participate in this drop. So while this is all happening, so all of these extrinsic had events. So I will just do it to you here. So we started with reserving balance, and then we create new asset and we minted it, and then we all of this are part of asset registered. Then we create a drop, and then we have Eve participate in the drop. Now, what final thing that we will be doing is we will execute this drop. That would mean uh, for Eve will be getting 10 units of that asset, and this would happen in a single shot. And if I submit transaction, you will see the explorer as soon as it is that some assets were transferred, and this is our event, that is the drop has been claimed, and we are for now I've just put the owner's account ID and the asset ID. So that is basically the entire what Palette does, and you can see that verifying this entire logic is so time consuming from the browser, and doing this every time you have a new extrinsic or a new logic change is something that's not ideal for almost anyone. So I just wanted to give you a gist of how this takes place if you use an Explorer. So I think now I'll get into how we will go about mocking this entire scenario that we just did inside a test environment. So yeah, before we do that, I think I'll also go through some of the palette code. And so far, are there any questions in the chat? Uh, yeah, so I currently do not have the source of this because I am right now. I quickly created this palette in. I think this is a Substrate 19 version. So I think I will create a GitHub and I'll share it with the Polkadot India team, and then they can share it to you. I think there is another question. Uh, so I think I do not know the answer to to this question. I guess so. This is not relevant to what we are talking about here. So I think I will skip this for now. Yeah. So I think if there are no more questions, then I'll go dive into the code of the palette, how the palette looks like, and yeah. So I think this is the palette. So I think folks have already gone through what a palette looks like. So I'll be really quick in explaining what the code here does. Also, I think I've kept some logic flaws here. If somebody can actually point out and tell me that this shouldn't be happening, that would be very nice. So basically, I have this config of the palette. So it is super small. I am just using this event, which is sort of boilerplate code. And I was initially going to use this module ID. So this is like the account for the palette. A lot of palettes use this for something like a custodian account. So ideally, I wanted anyone who creates a drop to transfer it to the custodian account, and the custodian account sends it. But I didn't have any enough time to implement this, so I think this we can ignore. And this is the entire assets palette, which you can find on Substrate. So this is responsible for minting the asset, transferring the asset, setting the metadata, and all the heavy lifting regarding the assets is done by this palette. And we are defining here. And by defining specific traits, we can access specific functions of this palette. So this is our struct of airdrop, which will have the owner, the asset ID, the max participants, and the amount. And this is just boilerplate code for creating it. And finally, we get to the extrinsics. So extrinsic are basically that these are functions that are run on the blockchain. So basically over here we have origin. So there can be different kind of transaction. There can be signed, unsigned, and inherent. I don't know the third type properly, but signed and unsigned transaction are most common. So here the sign we are using a signed transaction. That would mean that anyone who calls this transaction would have to obviously pay fees. And if it would be an unsigned transaction, then you don't necessarily have to pay fees, but you do need to write logic that will make sure that nobody spams these extrinsic, because the whole point of paying fees for transaction is to avoid any spam attacks largely. And here I am basically ensuring that if somebody has already created this asset or registered, then we do not allow the user to do it. And this will create the asset, this will set the metadata, this will mint it based on the values that we give. And finally, we deposit an event saying that an asset has been registered. And we are having a storage item that keeps track of this. So this is the first extrinsic, which will register asset. The second extrinsic, just simple extrinsic that just registers drop. And you can clearly see another logic flaw over here where I am not checking ensure over here. So ideally, somebody else also will try to insert and it will just overwrite what was already here. So yeah, so this is not production level code. So bear with me if you find any problems. Then we have join drop where people can participate in these drops. So basically, so I'm basically having a storage item. So if people aren't familiar with Rust syntax, so I'm directly taking a storage item and I'm calling mutate on it. So when I call mutate on it, I will get the value that it was storing, the mutable reference to it inside, which is the internal vector. And then I am directly pushing into that internal vector. So by doing this, I am reducing the read writes to the storage item. And I like the syntax writing this way. And finally, if this is done, I will deposit an event saying that someone has participated in this drop. So if you see the logic, you can also see I am not ensuring that if somebody is already inside this participant list, so some user, some malicious user can basically spam and be a part of this entire vector and get all the drop. So yeah, I think as I'm reading it, I am thinking of attack vectors. So then leave drop will basically allow a participant to leave it. And again, this is a Rust syntax. So basically I get mutate and then I'm doing retain. So whichever, whenever the user matches here, he will be removed. So, and then I'm depositing event, which will exit drop. And again, the same thing, unregistered drop will basically remove the keys. So that way the storage map will not have these keys and henceforth we are removing the storage item and we have this deposit event. And then finally, this is the most important part, I guess, because here we are actually moving assets. So we have the owner and we have the airdrop, and then we mutate it. So the reason why I'm using mutate over here is as soon as we transfer some funds to a participant, we don't want that participant to be a part of that vector. So that is why I'm taking this and calling pop. So pop will basically remove that item from the vector. So that way, after this function is executed, this participant will not be present in the vector, and therefore we reduce the amount of read and writes it takes to manually take read and then remove and then again overwrite. So this basically does that. And I think there is a flaw over here because we are only transferring for the user that has been popped and not the entire list of users here. So I think it should be something like while internal vector dot len is greater than 0, we run this entire set of thing inside this. So this will make sure that we execute the transfer for the entire participants. And then these are the storage items that we were using above. So these are very simple. So basically this will be the key and this will be the value. So we have two options here. So either it will be an option query. So when it's an option query, when you call a storage item, it could either be a sum or a null, or this could be a value query. So what value query does is that if suppose the key does not exist, then it will by default, whatever the default implementation is for this, storage struct that we're using or data type that we're using, it will fall back to that. For example, now we have vec t of account ID. Now let's say for a key one, there is nothing. But when you do call it, it will instead of giving you a none or an error, it will give you an empty vector because the default of a vector is an empty vector. So that is what a value query does. But at the same time, if you try to do one for this, when there is no airdrop or no struct inserted, it will give you a none value. So that is the difference between option query and value query. And lastly, we have a couple of events, asset registered, drop created, so I think these are quite obvious as we see them. So that is it with the entire palette syntax and palette code. So if there are any questions, uh, why and short sign for leave drop, fee for leaving the drop. Yeah. So the person who will be paying for that would be, so let me go to the code. So here, I think if somebody wants to leave the drop, so anyone who is part of the drop, they would have to pay the transaction fee to leave the drop. So as you can see over here, I am doing a participant over here. So this would be we get this from the signer. And then when we mute it, we are basically checking this function. So I think this is again Rust syntax. So what Rust does is that whenever this will return false for some value, that will not be retained inside this internal vector. So basically, this will be true for all the account IDs except for the account ID that actually stores the participant value, right? So I hope this is clear. So are there any other questions before we move on to the part where we are actually testing and seeing so that everyone's crystal clear on what we're trying to do here? Okay, so I would assume. The silence means no questions. So I think I already mentioned before that how you would do unit testing for an extrinsic is completely different than how you would normally unit test a function, because these extrinsic run inside the blockchain where anything they do will result in a new state for the blockchain. So for that, we have to create a mock environment, which we have defined in this module called mock. And this is something, I think, if people have already gone through the code, this is something similar to how you would define your palette inside the runtime. And what this does is that it basically defines the config for the palettes for this testing environment. So there are ideally four palettes that we are using, although, the because some of these palettes are sort of nested, like inside another palette. So you also see the balances palette. So asset manager basically uses this inside its config. So we also have to define it over here. So over here we give types. So the beauty of this is that we don't have to have an SR25519 key or something for the mock environment. I can just set the account ID to be U64 and put it over here. And then, so I think I will explain you how this works. So this is one of the convenience of writing, unit test for the entire extrinsic. And the same, whatever you do in the runtime normally, it's up to you what's preferable to you. Some people will directly use SR25519 key for more, I guess, accuracy or whatever. And then we basically, again, this is all configs for the palette balances. I will not get into this and the rest. So this is our palette, which is what we need. So ideally we have the event as an empty set, because also we don't care about it much. And we have the module ID that I think I already mentioned earlier, that I was initially planning on having this to be like a custodian account where users will transfer it to it, and when the execution happens, the custodian account will send it. So that way nobody runs away even after creating a drop. But yeah, I didn't get enough time to do it. And type asset manager would be assets, and this is the assets palette that we've defined over here. And this will be same, almost similar to how you would define the runtime, but changes based on what is available to you and how you would want to do this. And I think a rule of thumb, the way whenever I write tests, is that I actually go through these individual palettes that is inside Substrate's GitHub repository inside the frame palettes. So there you can already see these palettes have been properly tested and they already have a mock environment. So you can always read that as a reference and then build your own mock environment. And like I mentioned, that asset palette underlying uses a balance palette. So this is how where it is defining it, which we have defined earlier. That is palette balances. Yeah. So we've defined it. Is that? I think. Yeah. So I think it is this one. Sorry about that. This is just the balance. So this is palette balances that we are defining, and which asset uses for currency. So you cannot transfer, native currency using assets palette. You have to use the balances palette, and that is why assets has that. And I think I already showed you on the Explorer how I used sudo and went to the balances palette, and I did a set balance, extensive to make sure that we have the native currency. And I think the last part of the mock environment is the new test ext, this function. Now, what this function essentially does is that, like I said, a blockchain is a state machine, right? So we need something that works like a state machine, right? We give it something and it gives us the new state, and that is how we want the mock runtime to work. So this is provided by Substrate, where we can basically define the genesis. So this will basically create the genesis config. So this is very customizable. So you can directly endow some amount into some accounts when you do this. And I'm also setting uh, a new externality. And finally, I am setting the block number